We're going to take this derivative implicitly, working through term by term. I start with x cubed. I take that derivative for x cubed just like I always have. It's 3x squared. For y cubed, I follow the same kind of rules for what I just did with x cubed to get 3y squared. But because I was taking the derivative of y, I have to add the little label, my little notation, dy dx. That shows I'm taking this derivative with respect to x. On the other side, we've got this 6xy. Now, because I have a couple of variables here, these are being multiplied. That means I do have a product, and I have to follow the product rule. So as far as the 6 is concerned, just let the 6 join the x here. I'll have 6x times y. Following our product rule, well, we start with the derivative of this first piece. This is just an x term, so the derivative is going to be 6. Right? Since it's just an x term, I don't need the dy dx there. Continuing the product rule, we tack on this second part as is. We add the first part as is times the derivative of the second. So the derivative of this y, that's going to be 1, right? But we took the derivative of a y, meaning you have to add this label, dy dx. All right, next thing we want to do. We want to start, since we're trying to find what dy dx is, we want to start joining these dy dx terms together on one side, and then taking everything else and placing that on the other side. So what I like to do is I like to go through and find the dy dx's and see what is linked through multiplication. All right, so I notice the dy dx right here. I see that it is multiplied to this y squared to this 3. I'm going to group that. I'm going to highlight that. And then I notice I have a dy dx over here that through multiplication is attached to all of this, right? So I'm going to take these two pieces, I'm going to put them on the same side. So if I put them on the left side of the equation, I already have this piece over here, so that's 3y squared dy dx. If I want to move this over, since that's plus, I'm going to subtract it over. I'm simplifying a little bit here, right? I took the 1 out because I'm just multiplying that through. Now, the other parts. I've got a term here of 3x squared. I've got a term here of 6y. Let's put those on the other side. So I've got the 6y over here already. I want to bring this 3x squared over, so I would subtract it over. Now this is where we use that little trick I was showing you earlier, where we were solving for x, but I was showing you how to solve for x in a factoring kind of way. This dy dx is the greatest common factor shared between these two terms. So let's factor that out. Not canceling it out, I'm just factoring it out. Because I know I've got a lot of work going on here, I'm trying to eliminate some of this extra work. Knowing I'm factoring this dy dx out, what remains is this quantity right here of 3y squared minus 6x. That represents a value multiplied to dy dx that I can divide over. So dy dx is going to equal, you've got the 6y minus 3x squared that was over here already, divided by this quantity of 3y squared minus 6x. We've now solved for dy dx. We've got our answer. So we're trying to find dy dx, taking our derivative here implicitly. if we start with the left-hand side, got this trig function, we know when we take the derivative of something like sine, we get cosine back. We also appreciate there's a chain rule in play here because this x plus y follows that cosine. But then what are you supposed to do with that x plus y? You got to take a derivative of that, right? You got to tack that on. So, derivative of x plus y. Taking the derivative of x, you get 1. It's just an x, so treat it like we normally would. Plus, take the derivative of y. Well, we get 1 again. But we took the derivative of y, so we attach this dy dx. That equals, on the other side, we have y squared times the cosine of x, so that's a product rule. Start by taking the derivative of the y squared, which is 2y. We took the derivative of a y, so I need that dy dx label. So far, that's the derivative of this first piece. Continuing with the product rule, we tack on the second piece. And then add the first piece times the derivative of the second. Derivative of the cosine of x is negative sine of x. And that was already with respect to x, so we don't need the dy dx part. All right, so kind of like we did on the last problem, I started going through and highlighting where the dy dx's are, and I looked to see what is attached to those dy dx's with multiplication. For instance, over on this side, you got this dy dx, got a whole lot of stuff multiplied to it. So I know in a moment I want to move that to one side where all the dy dx's are going to be. What makes this problem a little more unique than the last one is you do have a dy dx right here, which appears to be attached to just a 1. But understand that this part, that's multiplied to that entire quantity. So anytime this happens where the dy dx is stuck inside parentheses, we got to distribute this out. So this is going to be one extra step on this problem we got to do. We're going to take this cosine of x plus y multiply to 1, which gives us cosine of x plus y. And then we're going to add, we're going to take this cosine of x plus y times dy dx. So I'm just going to write that all multiplied together. If I write the dy dx first, it would be dy dx cosine of x plus y. Now that equals, right, all of this. Where originally I was trying to find how the dy dx's were joined through multiplication to their respective terms. Now I can see that this dy dx is multiplied to the cosine of x plus y. I'm going to take these underlined portions, I'm going to bring them over to the left side. So, since this is already on the left side, I'm just going to rewrite it here. I want to bring this part over as well, so I'm going to subtract it over. As far as what that equals, well, that's going to equal basically the other pieces, right? I've got this piece that's already on the right side, y squared times the negative sine of x. And if I go back to this step here, I see I have the cosine of x plus y that was over here. I need to subtract that over. We're at the point now where we got the dy dx's on their own side, meaning we can factor out the dy dx. Whatever is left attached here to the dy dx, we can divide that over, and dy dx will equal, well, this green mess. That green mess divided by the blue mess we got to bring over. So that was the cosine of x plus y minus 2y cosine of x. There's your dy dx.